Welcome to Module 2 of our Prolog course. In Module 1 we saw the big idea: Prolog is declarative. You state what is true, and the system works out the rest. In this module we build the actual machinery you will use in every Prolog program. It rests on 3 pillars. Facts state what is unconditionally true. Rules derive new truths from existing ones. And queries ask the system questions. Get comfortable with these 3, and you can describe almost any world built from relationships. Here is the path for this module. We start with facts, the raw assertions that form your knowledge base. Then we add rules, which let Prolog infer relationships you never wrote down explicitly. Next come queries, the way you actually ask questions and get answers. Throughout, we use one running example, a small family tree, so the ideas stay concrete. By the end you will read a complete family program and watch it answer questions about parents, siblings, and grandparents from just a handful of facts and rules. Every Prolog program is made of just these 3 kinds of clauses. A fact, like parent of Pete, Ian, asserts something true with no conditions attached. A rule, like mother is a parent who is female, defines a relationship that holds whenever its conditions hold. A query, written with the question prompt, asks Prolog to prove a goal. A handy way to picture it: facts are the rows in a database, rules are the views computed from those rows, and a query is the question you run against the whole thing. Let us start with facts. A fact is an unconditional truth, a basic assertion about the world. The syntax is simple: a predicate name, then arguments in parentheses, ended with a period. 3 rules of thumb. Predicate names and constant values start with a lowercase letter, so parent, Pete, and Lucy are all valid. Every clause, including a fact, ends with a period. And each fact should state one single thing. Think of a fact as a single, indivisible row of knowledge that Prolog can match against later. Here is our running example, a family tree expressed entirely in facts. The parent predicate records who is a parent of whom. Lou is a parent of Pete and Pauline, Pete and Cathy are both parents of Ian, and Ian is a parent of Peter and Lucy. A second group of facts records gender, using female and male predicates. Notice that we never draw a tree in the code. We only state individual relationships. The tree on the right is something Prolog can reconstruct from these facts, and that reconstruction is exactly what makes the language powerful. Facts are not limited to family relations, and they are not limited to 2 arguments. The number of arguments a predicate takes is called its arity, and it is part of the predicate's identity. Age of Ian, 45 is a binary fact pairing a person with a number. Likes of Lucy, chocolate records a preference. Capital of China, Beijing is a geographic fact. And course of CS 101, AI, 3 is a ternary fact bundling a code, a name, and a credit value. When you write facts, keep them atomic, keep them consistent, and use predicate names that read clearly. Facts alone only tell Prolog what you typed in. Rules let it derive what you did not. A rule has the form head, body, and you read the as the word if. So the mother rule reads, X is the mother of Y if X is a parent of Y and X is female. The comma between the 2 conditions reads as and. The head is the conclusion, the body is the set of conditions that must all hold. With one short rule, Prolog can answer questions about motherhood for every person in the family, without you ever storing a single mother fact. Inside a rule body you combine conditions with a small set of connectives. The comma means and, every condition must succeed. The semicolon means or, any one alternative is enough. + is negation as failure, it succeeds when Prolog cannot prove the goal inside it. And == means not equal, which we will need shortly to keep a person from being treated as their own sibling. The grandparent rule shows 2 conditions chained with and, X is a grandparent of Z if X is a parent of some Y, and that Y is a parent of Z. Let us watch a rule actually run. We ask, is Cathy the mother of Ian? Prolog first unifies the query with the rule head, binding X to Cathy and Y to Ian. It then replaces the goal with the rule body, giving two subgoals, parent of Cathy, Ian, and female of Cathy. It solves the first subgoal by finding a matching fact, then the second the same way. Both succeed, so the original goal succeeds and Prolog answers true. This pattern, match the head, expand the body, solve each subgoal, is the heartbeat of every Prolog computation. Rules are powerful, but a careless rule can be quietly wrong. Consider a first attempt at sibling. X and Y are siblings if some Z is a parent of both. It looks right, and it does say that Peter and Lucy are siblings. But ask whether Peter is his own sibling, and it answers true, because Peter trivially shares a parent with himself. The fix is one extra condition, X is not equal to Y. Now a person is no longer their own sibling. This is a recurring lesson in Prolog. The obvious rule often admits a degenerate solution you never intended. Now to queries, the way you actually talk to a Prolog system. A query begins with the question prompt, followed by a goal. There are three flavors worth naming. A ground query, like parent of Ian, Lucy, contains no variables and simply returns true or false. A query with a variable, like parent of X, Ian, asks Prolog to find values that make the goal true. And a compound query joins several goals with commas, asking for one binding that satisfies all of them at once. In every case you are asking Prolog to prove a goal, and its engine searches for a way to do so. Variables are what make queries expressive. A variable, written with a capital letter, is a placeholder for something Prolog will fill in. When you ask parent of X, Ian, the system answers X equals Pete, the first solution it finds. If you press semicolon, you are asking for more, and Prolog backtracks to find the next answer, X equals Cathy. The same relation can be queried in either direction, parent of X, Ian finds parents, while parent of Ian, Y finds children. We open up exactly how this search works in the next module. For now, notice that one fact base answers many different questions. Here is everything assembled into one small program, a handful of facts about parents and gender, and a stack of rules built on top of them, including mother, father, sibling, and grandparent. From this single program we can ask a remarkable range of questions. Who are Ian's parents? Is Pauline a sister of Pete? Who are Lucy's grandparents? Each answer is computed on demand by combining facts through rules. This is the payoff of the declarative style, a compact description of relationships, and a system that does the searching for you. To recap, Prolog programs are built from three kinds of clauses. Facts assert unconditional truths. Rules derive new relationships using the if, and, or, and not connectives, and they execute by matching a head and solving the body. Queries pose goals for the system to prove, and variables let one question explore many answers. What we have not yet opened up is the engine itself, how Prolog matches terms, and how it searches when a path fails. That is exactly where we go next, in Module 3, Unification and Backtracking.